Hi, everybody, and welcome to this meeting for our Astronomy 120 in the spring of 2023. Today is January 23rd. And as I was explaining to some of you earlier, in that the scheduling is a little bit different than what is announced on Zoom, on the syllabus. In a sense, Zoom goes by 12 or 12:30, so it doesn't go by 12:10. So we're doing this meeting at 12:30 instead. Anyway, we're going to have somewhat regular meetings in the semester. They're going to be on an as-needed basis, and I will explain what that is. Most of the work for this class is going to be on Canvas. So I know we started last week. Last Tuesday actually was the first day of class. Today, tomorrow is going to be exactly a week after. So I know that there are also a lot of assignments that are there. A lot of you also did submit your assignments for the first two assignments, but a lot of other you, about half of you actually still did not submit them because the due dates are actually still coming. So hopefully you guys will take care of those due dates and follow up the course basically, and how is it outlined on Canvas. So this is in terms of this class in general, how it's going to be structured. So let me share with you the class so that you guys have an idea. I know I already have postings on that, especially for those of you who have already submitted to, or at least went through the YouTube subscription and subscribed to the channel. So you saw that there are a lot of videos for these classes that I've been doing in the past. And some of you actually have been watching these videos. I wouldn't recommend that approach, honestly. I would still recommend that you guys subscribe to the YouTube channel, at least during the semester, during the spring of 2023, because any updates, any postings, you will have firsthand at them. And but also trying to follow the course from the modules, content from the Canvas. So let me share with you the screen. Let me move this out of the way for a moment. And let me go to open the window and make sure I'm on the home page first. And let me share. I want to share the entire screen. I will just share the content. Okay. So this is basically what you guys do when you first come into this window in here. And for some reason, yeah. This is basically the window that you guys see. This is the introduction. This is the syllabus that you guys have received also in an email. This is download the PDF version, or you go online for it. There is an open topic discussion item in here that you can always ask questions in general. And these are not graded assignments in the sense that you guys are if you're asking cooperation with your peers, if you want to work together with your classmates, this is the place to go. So, and I will talk about the two types basically of assignments that you will definitely need to work with your peers. Not required, but highly encouraged, okay, to work with your peers. So this is a good place to go and start looking for peers to work with and get help in terms of how to do these things, okay? This is the page where the modules are. So this is basically the one I was talking about. This is where you need to follow your course outline. Every week, they have more or less the same format. You will have objectives of the week, the content of that week, the discussion item for that week, and then the PowerPoints, if you wish, for that lecture. This book that you guys have, namely the Pathway to Astronomy, is actually a very good book in a sense that it makes the content a little bit manageable in terms, not in terms of chapters, or chapter basically going through everything, but in terms of units basically. And the units, they are actually small number of pages. They are like handful of pages, 6-7 pages at most. Sometimes probably a little more than that, but the point being in here, they are manageable. You can read those units and then finalize the idea and move on to the next units and so on and so forth. But because of that, some weeks we have a couple of units, some weeks we have more so or less, depending on the week. Like for example, next week we will only have 1 unit, okay? And this week we have 3, the week before we have 2. So that is basically the idea behind it. Anytime we have content that need to be concisely in that approach, we do it that way. It's still, for your reading, go through the book and read those entire units, come into the PowerPoints in here and look at them. As I was saying, these are my previous classes. We used to hold weekly sessions because they were required actually to have them. But because this is an online class, you're not required to attend live sessions. So basically you have the recording. So you benefit from that in the sense that these are discussions with the very same units. So in case you have still questions after you read the unit or go through the summary of the PowerPoint, you still also have those video recordings. And they're like this one in here from 2 sessions, basically. And those are, as I was saying, they're the same concept, the same classes, the same units, as a matter of fact, it's the same content, okay? If you still have questions, please do not hesitate to reach out, okay? It's very important that you guys go through understanding the material and going through it so that and going through the recordings and make sure that you understand everything before coming in here. For example, as I was saying, this week I have 2 assignments. One of them is, both of them are actually due the 28th, and today is the 23rd, so they are due this weekend. And each one of them are graded, so make sure you go through the grading. If I open this assignment, for example, it's telling me that it has actually 2 components. One of them is due on Wednesday, 2 days from today, and the other one is due on the 28th. Most of the times I'm looking at it as an instructor, so technically I really should look at it as a student, just like you guys, okay? And this is basically how it looks like, okay? If I am doing any assignment at all in this class, you will see them that they have rubrics. So instead of basically going and trying to understand what's going on in here and see the assignment, I could go just to the rubric and see how am I going to be graded in here, okay? The rubric is a little bit outdated in terms of the date in here, but the idea is the same, okay? The first portion, you need to get 10 points for it if you include the 4 items. So the 4 items, what are they? They're again this 1, 2, and 3, and 4, okay? So that is actually a good starting point for your assignments. All assignments is to go to the rubric, see how you're going to be graded, and follow the rubric to make sure you meet all of the requirements by the due dates, so that you get your credits. Let me go back into the models again where we were. So I'm still looking at it as a student now. I'm not looking at it as an instructor. So as a student, you guys see that the items now are locked, because we're supposed to do week 1 and week 2. So those are the 2 things that we need to be focused on. As I was saying, those are not the only 2 types of assignment, namely discussions, the first one and this week, and the last week and this week, but you also have quizzes, and down the road you will have homework assignments and more homework assignments, and so on and so forth, okay? So these are the types of assignments that you will have. Now, when it comes to homework assignments, in the videos I was describing, you should be able to find the help you need. Now, if you don't, please reach out again to me, okay? I don't want you to be looking at an assignment and not knowing how to start it for more than 5 minutes. If you think that it's getting too much, wasted about 5 minutes or more on the assignment, reach out to me so that we can basically get it going and probably go through the entire assignment so that you benefit from it. The purpose of homework assignments actually is to reinforce the content, to reinforce the ideas that are touched upon in the lectures. So you need to be able to do them and do them correctly. It's not an exam. Homework is not a test. Homework is just a practice so that you can understand what's going on. Now, if you can't start it because, for example, you did not have experience in these ideas before, you didn't do assignments like this before, or you probably did, but they're not connecting, especially since the topic being new to you, please reach out, okay? Don't let it stand more than it should, okay? You shouldn't be spending more than 5-10 minutes at least to get started on it. You may need more time to finish it, but if you think that you're spending half an hour on it or more, that is way too much time, reach out so that we can get it done, okay? As I was saying, if you go through the recordings that I did in the past, you should find the help in there, but they may be overwhelming also. So if it may become too much, please reach out so that we can have those done. Okay. Does this sound good for the people who are here, at least in terms of the homework? Yes, no, maybe. You guys hear me? Oh, okay. I see something. Yeah, okay. Very good. Thank you, David. Thank you, guys. Okay. Sorry, I didn't have the chat open. That's why I was okay. So anyway, so that's basically the idea behind this homework assignment. This is one type of assignment that you definitely will benefit from working with peers. So remember that item, as I was saying in the beginning, when you go back home, this is a good place to seek help with your peers. Go to the open topic class discussion. This is not a graded assignment. It has no date on it whatsoever. You can just basically start up a discussion in there, and it's a good idea to check from time to time, okay, on it, so that you can come in here and seek help with your peers. There is no shame in it. As a matter of fact, it's very good. This is actually a good skill to take with you from this class to your workplace, in a sense that you can work with your peers. So this is actually a good skill to do. So homework is one assignment that you're going to be actually a good idea to work with peers on it. So let me go back to the models. Okay, in addition to the homework assignment, so those are, so far we have learned about the discussion assignments that are graded, also the homework assignments that are graded. There is a project. For this class, you will have 2 projects, okay? The first project will be posted soon is for you guys to work on the lunar observation. You're going to monitor the moon for 4 weeks, okay? You'll be given the date when to go out, and what to look for, and what to report, okay? And basically that is one observation, the week after another observation, the 3rd week another observation, and the 4th week a final observation, and then you compile all of your observation and you post them in here. Again, projects, it's a good idea to work together. They should be a lot of fun for you guys to do. This is one. The other project, you will have basically to monitor, you'll be given data, and you will be plotting the path of Mars, okay? Again, because some of you actually probably did not come from the math background and probably did not have a lot of experience in terms of graphing and looking at data and trying to put them on some sort of a surface, I'll give you a full, basically, discussion, full guide on how to do the project. Both projects, whether the lunar observation or the orbit of Mars, okay? The purpose of the orbit of Mars, and it will not be available until we do Kepler's laws, and Kepler's laws there in the next few weeks, you will explore them. Once we explore Kepler's 3 laws, we will take Mars as an example, and we're going to observe the first law of Kepler for the planet Mars, okay? So that's basically the idea behind the second project. Again, projects are graded assignments. Please take care of them. And as I was saying, both the homework assignment and the quizzes and the project, they reinforce everything you learn in class. Because it's one thing to learn the 3 laws of Kepler and even probably memorize them. And maybe even a year from now, after you memorize them, somebody asks you, may be able to even recall them. But it's another matter altogether to take those laws, for example, or what you learn about the concepts in astronomy, for example. I know right now we're doing the coordinates of objects using the celestial sphere. Take all of these concepts that you learn and then apply them to something. That level of understanding, when you apply something, goes a step beyond that, and things will stick a little bit better for the long term. I'm not asking you guys to memorize concepts. As a matter of fact, this is actually not something that that is going to be beneficial to you guys. So, but knowing the concept and applying it, that is how you learn. That is how you actually retain knowledge. But if you just learn about it just like that, it's not going to be retained. So, again, projects and homework is a good idea to work together with your peers. As I was saying, I will be posting recordings for you guys on how to do, especially the projects, both projects. One of them, actually, honestly, the lunar observation should not really need more than minimal, basically, instructions, because it's going to require you to go every evening on those days, or morning, because you're supposed to go in the evening, look for the moon. If you don't find it, you're supposed to go in the early in the morning trying to find it, because chances are, if it's not visible in the evening, it's going to be visible in the morning. Although there is an instance where it will not be visible no matter what time you go out, okay? But that's part of the cycle of the moon that you're going to be exploring and reporting to it. So that requires more of a field observation than actually a ruler or a pencil trying to draw something, okay? The other project is the one that requires a pencil and a ruler and protractor trying to find the position of Mars over a span of time. So this is in terms of assignments. Of course, we will have our midterms, and everything is posted on Canvas. Everything is available for you guys there. You have my contact information. I usually try to respond immediately for you guys, so please send those requests, and I will be more than happy to answer it. I know this is an online class, and I know it's not a synchronous class, it's an async class. Some of you, and a lot of you actually, are not here right now because they're watching this one recorded. So it's still, if you need something, especially a question on a homework or a question on a project or something, we can schedule a live meeting online or in person. On Tuesdays and Thursdays, I am on campus all the time. So that's probably what I'm going to reach. If you're going to reach me online, that's where I'm going to be having a meeting with you online. And the other days I will be basically working off of home. Although on Fridays and even on Wednesdays, I may be also on campus too. What I'm trying to say in here is we can still meet in person if you choose to, okay? My office is office number 195 in the, what is it called again? The science building, I guess, next to the health science building. The physical science building, okay, I lost the word now. In the physical science building, office number 195. But also on Wednesdays, actually, I'm sorry, on Thursdays, actually, my office is in the STEM Center. I don't know if you have had a chance to go to the STEM Mesa Center, but if you don't, it's a good resource for you guys to go and use, especially if you have questions and how to do something. This is actually a very good place to go. On Thursdays, as I was saying, I will be actually in the STEM Mesa Center. And as I was saying, the third option is to do these things online. And in either case, if the question can benefit everybody else that you're raising, and I'm hoping that you guys bring all kinds of questions to the class to enrich it. If it benefits everybody else, then I will share it with everybody else in the class, okay? Some of you are sitting in my Astronomy 125, which is the lab version of this class. It's not a required class for you guys. But of course, if you are sitting in Astronomy 125, we will start meeting on the 16th of February, because it's a late start class, and it's going to be in room 216 in the second floor, basically in the physical science building. And it's actually a fun class. A lot of my students actually enjoy that class a lot too, because of the fact that we will be using a telescope remotely from Australia, getting the data off of it and basically doing the observations for all kinds of objects, whether Jupiter and its moons, or the Pleiades, which is a bunch of stars in the Taurus constellation, and also Taurus also, which is another star that we'll be looking at using that telescope. So it's a lot of fun basically to do. We will use actually another software which I have ready in here trying to share with you guys, because actually it's another resource that is actually useful for this class, and that is the planetarium. I know planetarium, sorry, the stellarium software. And I know I posted the link for you guys on the syllabus, so I'm hoping that you guys have already downloaded that. Okay. Any questions so far?
Yeah, I have one question.
Go ahead.
Okay, so like for the first assignment, is the Earth is flat? We just pre-read the textbook, the units, and we watch the lectures, and we'll be able to do that assignment.
Actually, the instructions, I don't think that they are asking you to do that, but basically what the instructions are telling you is that go on Google or YouTube or Wiki or whatever your resource is, and look for people who argue that the Earth is flat. Okay, find somebody who says, you know what, the Earth is flat, and here is why the Earth is flat, and share that link with us. Okay. And then try to present their arguments. Try not to make it too long, okay? Just basically briefly, this is why they think the Earth is flat. And what do you think of what they say? Is this something true or not? That's all. You don't really need the textbook for that.
Okay, I understand now.
Okay, very good. Yeah, it should not be hard for you guys to. I mean, if you can find the resource, please let me know, because usually it's YouTube. If you go to YouTube, the Earth is flat, and you'll find now a bunch of people who are arguing actually the Earth is not flat, and that's actually a good resource too. Hey, the Earth is not flat, and this is why it's not flat. I mean, I know in the textbook it shows that the people have argued that the Earth is not flat from the time of the of the Greeks. So from Aristotle, basically, so you can go in the book and see why Aristotle and the Greeks and everybody else in the old times, way before YouTube came in, argue that the Earth is not flat, and actually they were able not only to argue that the Earth is not flat, and that it's a sphere as a matter of fact, but they were able to measure its radius with tremendous accuracy. Actually, it's a very good accuracy. So just to show you guys that now with YouTube being here and the social media in general, not just YouTube is guilty of that, people are trying to advance some of their likes and all of these things, trying to advance some, let me stop sharing in here. To advance the likes and the, you know, the sharing and all of these things. So they come up with all kinds of outrageous claims, okay, such as the Earth is flat, and start to make all kinds of things. And not only that, but they have followers too. So just to show you, and they make money, okay? But it become popular because you're taking an astronomy class and you would be asked by probably people in the street, I mean, or at work or somewhere else that you meet, hey, I heard so-and-so, they're saying that the Earth is flat, and this is their argument, okay? So that's really the part of the discussion that I'm hoping that you guys will take it from this class and actually refute this nonsense arguments, okay? Sounds good?
Yep, sounds good.
Okay, very good. Listen, the other question is probably related to your question, and it's an important one since you brought it up, and I'm glad you did, is the fact that the other assignment, the discussion for the week, is actually related to the textbook. That one you have to read the units. So that one you have to read the units before you start answering the questions. So there are two types of discussion items. Make sense?
Yeah.
Very good, thank you. So the other software that I wanted to make sure that you guys have, and I'm hoping that you guys will go ahead and download, is Stellarium. So let me make the Stellarium a little bit bigger on my screen in here, and let me share it with you. Share Stellarium. Okay. Again, if you're taking Astronomy 125, which is a class on campus, the lab version of this class, this is actually a very good software that we will be using, among other things, to track the position, the position of the sun on different dates, especially the 4 dates that are known, the 4 dates of the year where the sun makes the big turn. Namely, we just came off of the winter solstice on December 22nd. Then on March 21st is the spring equinox. Then on June 21st is the summer solstice, and then the fall equinox is going to be on September 21st. So those are the 4 dates where you're going to basically, for those again taking those class, but for your class also you need to know about these dates too, because they're part of the path of the Earth around the sun too. So those are the important dates that you're going to be monitoring the position of the sun. Obviously, the sun is the lowest in the sky on December 22nd, 22nd usually, namely the winter solstice, and then it's going to be the highest in the sky on the June 21st, which is a summer solstice, and then somewhere in between on the other 2 equinoxes. Okay, and the day is the shortest on around December 21st, 22nd, on the winter solstice, and the longest, I mean, on the winter solstice is the shortest, and the longest time is going to be the daytime. That is, daytime is going to be the longest on the summer solstice, and it's going to be exactly 12 hours on the equinoxes. So this is some of the stuff that you're going to be learning in this class. But again, if you're taking 125, you're actually going to do the measurements and the observations. And the tool to do that for is this software. Okay, and the software actually will help you also in the same time to track the position of the sun versus the background stars. Okay, so right now, if you open it, for some reason it thinks I'm in Fontana, but I'm not. I'm actually here in San Bernardino, and I guess it takes the IP address and it bases it off of it. It's not really taking your physical address. So I just fixed it. It thinks that I'm in Fontana, but I can always change my location in here. So right now it thinks I'm in Fontana. I can change the location to San Bernardino. So the minute you write the first few letters of a word, it's going to zero in on where you are. So obviously I'm in San Bernardino, North America. I don't know where San Bernardino this thing is in Central America and one in South America. I want this one. So now it barely changed anything, okay? But if you notice in the bottom, if you notice here, the latitude and the longitude, especially the longitude, should change between Fontana and where we are. It's not much at all. I mean, the distance is not even 10 miles. So the changes are not going to be much. So it's showing west coordinates 117 degrees, 17 arc minutes, and 23.18 arc seconds. So if I go back to Fontana, North America, note the last numbers, okay? It changed from 23 whatever to 26. It stayed still when it was 117 degrees and 6 points. So let me go back to San Bernardino. That's where I am at. So if you are somewhere else, make sure you put your location in that. Not only that, but you can change the time. Actually, right now it's showing 103. This is military time. It uses military time. So it starts with the year, the month, the day, and then the hour, the minute, the second. Okay, for one thing, I can come to the bottom in here and pause time. And it's important to do that at times, to pause time, to stop the clock, basically. And let's, for example, look at the night here, where I am at 10 p.m. 10 p.m. is 2200. So this is basically how the night would look like if I am facing south. If I am facing south, south is just this way, you will see a bunch of things. The brightest star in the sky, of course, is Ceres. That's the brightest star for us in here, okay? Ceres. And if I click on it, Ceres is basically part of it's called the dog star. It's part of the Canis Major. If I click on it, and here it gives me more details on it. So this is basically the star. And it's telling me it's a double star. One of the things we will be learning down the road is that there are different kinds of stars. Sirius is two types of stars. There is actually a Series A and Series B. Series A is the one that we see actually with the normal eye, the naked eye. And Series B is actually a white dwarf that has gone through its all life cycle, basically. Now it's ended. And it's next to it. So it's a double star, okay? And it shows you the magnitude, a concept that we will be learning later on. And the magnitude, the smaller the number, the brighter the star, okay? It's the counterintuitive. I mean, you would think that the higher the number, the brighter, but it's the opposite. The smaller the number, the brighter the star. So right now, if I compare that, for example, to Rigel, this one is negative 1.45, and Rigel is 0.15. Of course, a negative number is always smaller than a positive number. Rigel is a positive 0.15, whereas Ceres is a negative 1.45. So again, this is one thing that I can be looking at, of course, on the south. And another object, and I really encourage you to go tonight and look at these things. Tonight is supposed to be a clear night, at least here in Southern California, if you are here. I know at least one of you is not in Southern California, is somewhere in the Midwest. But look at the sky. And even if you are in the Midwest, it's going to look not much different at all. Okay, it's going to be the same thing. Okay, so we're going to be seeing the same thing. This is what is known as Orion belt. These three stars are part of the belt. Okay, Betelgeuse is here, and it's actually a beautiful star that you can see in here, and it's a yellowish star that you can see. And you will look for this pattern: three stars followed by a star, bright star in the bottom, and another bright star in here, and another bright star in here, which is called Safe. And this is Bellatrix. All of these four stars, or at least this pattern, form what is known as Orion the Hunter. So this is actually a very, very beautiful thing that you can see tonight, okay? I don't know for the one who's in the Midwest right now, if the weather is clear or not, but if it is not clear, wait until tomorrow and you should be able to see the same pattern. This is at 10 p.m. in our location, okay? Bellatrix, Ceres, Procyon, and I know you're learning this concept right now, are part of the winter asterism. This is a pattern that you will see in the winter. There's three stars, they form a triangle, almost an equilateral triangle in here. The distance between Procyon, Ceres, and Betelgeuse is the same from all of three of them. Obviously, as I was saying in here, these are the belt of Orion, and this whole constellation is the Orion constellation. This is Canis Major, okay? Basically, Orion is a hunter, and this is his shield, this bunch of stars, and he's trying to shoot the bull, basically the Taurus, and this is the eye of the Taurus. This is Aldebaran. Aldebaran is a reddish star, just like Betelgeuse. That means you will see later on down the road, around the units 80 and something, where we're going to be talking about the end of the cycle of the stars, and this are toward their end of the life cycle. As a matter of fact, Betelgeuse can go supernova anytime today. I mean, anytime, okay? Within the next 10,000 years or so. But the point being in here, these are the stars that are toward their life, to end the end of their life. Mars also is visible tonight in the sky, okay? As a matter of fact, if you are around that same time, Uranus, you cannot see it even with a good telescope. You should be able to find even where, actually early at night, let me zoom out a little bit, early at night, you should be able to see a Jupiter. The other day, we looked at it, let me find it in here. Where is Jupiter? It's probably just went below the horizon. Yeah, it did, okay? At 10 p.m. So if we take the clock back, so if we go, where is the time? If we take the time and not look at it, let's look at it at 9 p.m. tonight. 9 is 2100, and Jupiter is just above the horizon. So if you have a telescope, this is actually a good thing to look at, and you can actually zoom in with this software, and you zoom into it and you see Jupiter with all of its four moons. You have Europa, you have Callisto, Ganymede, and Io. Oops, no, where is Io? Io is actually behind the star, okay? It's behind the star, okay? Behind the planets. I don't know if you can see it from here or not, but actually there is a, or at least actually it's in front of it, okay? So those are the 4 moons of Jupiter in terms of distance, of course, and this is part of some units that we'll be learning down the road around unit 40 something, 47 or 48, I don't remember the name of the units exactly. Those are the 4 moons of Jupiter that Galileo has discovered. And if you have a telescope, you can go tonight. This is the star, actually, far away from the star. You can go tonight and actually look at these objects in here. If you're taking Astronomy 125, we just bought 6 new telescopes for our lab, and we will be using them for our, first of all, to see how a telescope works, and then we probably you can use them. For those sitting in Astronomy 125, we will be using a remote telescope to look at the Jupiter itself with all of its 4 moons and track them from night to night to night. Actually, for Io, because it's super fast around the planet Jupiter, we're going to track it every 6 hours, but the others will track it around 12 hours or so. Every half a day, we'll see where they are, okay? And we'll deduce a lot of things. Among other things is to find the mass of Jupiter, okay? So again, this is a nice software you can have, short of having a telescope if you don't have a telescope. It's a free software to have it on your computer, whether it's a Mac or a Windows or a Linux, it doesn't matter which machine is, it's free. But if you have a phone, it's costs you a little bit more money. I think it costs $4 or $5. I don't remember exactly how much. But granted, the phone version is limited. You can even go on websites and do the web version of it for free on any website. And the website and actually the phone version are the same. On the computer, it's far more flexible, and you can do all kinds of trackings for it. So again, this is Jupiter, and this is how the night sky would look like. I know right now you're taking the position of the objects in the sky, and one of them, if I look north, which is the opposite of where I was looking, this is south, so this is north. And if I go straight up in the sky and look at an asterism that is out there, and I look at this star in here, this is immediately above the north, my north in here, okay? About 34 degrees. How do I know 34 degrees? You're asking? Good question. Let me show you why, okay? If I go back to my location, we are north 34 degrees. That's our location. If we are 50 degrees, we have to look 50 degrees because this is basically our location right now. So it's about 34 degrees. So extend your hand like this and raise it, not between up north. This is called the zenith. This is the horizon, just somewhere around a little bit above the quarter of the way. That is, you should be able to see. Of course, I should be doing it back behind me because that's my north. That's what Polaris is. It's not the brightest star in the sky. And I know there is a discussion about it, at least down the road in my homework. But at least it's always the one that does not change location in the sky. Okay? So one thing that you should be able to look at also is the shapes that are formed in the sky. So I'm turning on the shapes. And this is Ursa Minor versus Ursa Major, which is actually another constellation in here. Okay, let me turn off the horizon. Okay, I'm looking as if I'm basically suspended in the air right now. Okay, so that we can see all kinds of constellations in here. This is Ursa Major next to it, the Big Dipper, and this is, if you wish, the Small Dipper. If you look at the stars tonight, they're faint stars compared to this ones in here, and the shape looks similar. But if you extend the 2 sides of Ursa Major, and that's where actually Polaris is. So let me put back the horizon. So this is how they look like, at least for you guys, in the sky. One thing I know we're doing right now is how the shape of the sky changes. So I'm going to go back into the time and change it and allow the time to move. Right now, if you look at the the time, it's ticking, and it's taking the normal second. I'm gonna move the second now and have it move faster, and you will see what's going on in here. What Cassiopeia, which is actually another object in here, it's right now number 3 backward. Okay. Okay, so 3 should be in the opposite direction. At some point at night, it's going to be W. Okay, just above the horizon. So everything seems to be moving, and it's moving around Polaris, around the star. Okay, this is the center of everything in here in the sky. And at some point, Cassiopeia now is showing up again. Okay, it's going to be a 3, and at the end it's going to be an M, and backward 3 and M and everything else. Obviously, if you wait for an hour, the reason why you see this motion at all, of course, we're going to hit daytime very soon now. Right now, the time is 12:30 in the evening. It's 1:20, so very soon the night starts, I mean, the sun starts to rise in the east, in the west, in the east, and then it's going to fall in the other direction. So the point being in here is everything rises off of the east, and everything falls toward the west. Okay. And we removed the effects of the atmosphere too. Anyway, the point being in here is, what time is it now? Did it go daytime already and I missed it, or what? I think I probably did. It's 1 o'clock in the morning, 2 o'clock in the morning, and we are actually on the 25th, 3 o'clock in the morning. This is around sunrise. Sunrise should be, right now the sun has risen. Yes. Okay, very good. So let me pause it in here. Oops, I made it go faster. I'm sorry. The point being in here is that you can simulate all kinds of things and watch objects that are that can move in the sky. Let me pause it completely. And the whole reason why these objects are moving in the sky is because the Earth is spinning in the opposite direction. It's like when you're driving in a car, and if you're moving and everybody is sitting, but if you don't know that you're moving, you think that everything is moving in the opposite direction. That's all. If you're sitting in a train, for example, next to another train, and your train moves, you will have the impression that the other train is moving backward, but it's not. It's your train is moving forward. That is actually the same thing in here. It's because the Earth is spinning, and it's going from west to east. Everything appears to be rising from the east to the west. Okay, and the Earth goes one full day, 24 hours, makes 360 degrees. So if I take 360 divided by 24, I find 15 degrees. Every 15 degrees will equate to an hour. Every hour, those objects, they will move in the sky by 15 degrees, 15 degrees, 15 degrees, until after 12 hours, they move half a cycle, 180 degrees, basically. 24 hours, they move forward. You will find them back where they started from. So if you wait an hour, for example, for Cassiopeia, you will see Cassiopeia, for example, change location from here to here. So that how you could tell time too, and you can tell your location. Cassiopeia is the 3 big stars, and not 3. I mean, there are 5 stars that form the letter W or M or whatever shape you can think of, or 3 or backward 3, if you can think of it that way, depending on the night when you're looking at it. The constellation, and I know you're learning about all of these things at once right now. There are 3 types of constellations. Those that stay in the sky, like for example, Ursa Minor stays in the sky all the time. And that is actually a circumpolar constellation, in the sense that it stays all the time with next to Polaris, next to the pole. Okay. And then you have the signs of the zodiac, the 12 ones, basically, of the signs of the zodiac, and those they change basically depending on the year, 12 of them. And then you have the constellation that basically seasonal constellations, they are called. Okay, so those are the types of constellations. There are 88 of them. You don't need to remember all of them, but it's at least a good idea to recognize some of the shapes so that when you go outside at night, you can recognize some of those patterns, start to find your way. Like, for example, where is Polaris? Where is Orion? Where is Draco, for example? Cygnus, and some of these constellations in there. Okay, so I intended for this whole meeting to be an introduction again for this whole things that we're doing in this class. I'm hoping that you guys will download the software and start playing with it and trying to recognize the patterns in there as you're learning the units, as you're going through the units. At some point, you're going to be exploring Mars. Not much really, but if you're going to be exploring more Venus, and we're going to be talking about Mars still, you're going to be looking at both Jupiter and Neptune and all of these objects and the stars and the different kinds of stars. I know at least I mentioned the white dwarf type for today for Ceres, and also the regular stars, the main sequence stars. And I mentioned actually some giants and supergiant stars today, Betelgeuse, and all kinds of objects in the sky. Sounds good? Are you guys excited or not?
Yeah, sounds good. Excited.
Okay, very good. So please reach out to me. We can have more meetings like this ones on a regular basis, but because the class is not really intended to be a synchronous class, that's fine. We can have them on as needed basis, especially for projects and homework assignments, and especially for the review for the exams. Thank you, guys.
Okay, well, one question.
Yes.
The Stellarium, do we need to download it, or is that something like you want us to just experience and?
It's a highly recommended thing to download. If you can download it, at least to explore the web version of it, okay? To go on the website, okay?
Okay.
Because it will help you a lot in the class, right? To visualize those things and play with them.
Okay, thank you.
Okay, thank you, guys. Thank you, Ariana. Thank you, Andrea. Thank you, everybody. I'll see you guys, okay? Please watch for the announcements too, because that's basically how we can keep in touch too. Thank you.